Okay, this time we'll just work straight through a couple just to make sure we're actually seeing what's happening here. And so what do we have here? So is it clear what we're going to let u equal? Yeah, I think it's pretty straightforward. We should be used to this by now. This is now becoming, I hope, familiar ground. Let u equal to 5x to the second plus 4. And so we've accounted for this piece. Now what we have left over, unaccounted for? This has been accounted for. What we have left over is x dx. Whatever is unaccounted for, here's the u to the 1/3, or u to the 3rd power. Whatever's left over, that's what we want to create on this right-hand side here. So first, find the derivative. The derivative here is 10 x dx. I don't want 10x dx, I just want x dx. So we need to multiply both sides of this expression by something to get rid of this 10. And I think it's pretty straightforward to say that the multiplier needs to be 1/10. And the substitution is exact. So this should by now start to be fairly familiar. You practice this 3 or 4 times, and I think you'll have this. So now substituting, this is equal to, instead of stuff to the 3rd power, that's u to the 3rd power. Instead of x dx, that's 1/10, which I'm going to stow out front of the integral. 1/10 du. And now this is straightforward. This is 1/10 times. This is u to the 4th over 4. And then what was u to begin with? U was 5x squared plus 4. So what we have is 5x squared plus 4 to the 4th power. It might not be asking too much to say bottom times the bottom. 10 times 4 is 40. If you don't combine those, that's fine. But I think it's probably not asking too much to say 10 times 4 is 40. And so that's pretty straightforward for number 16. Number 16 was, of course, Joe Montana. Also Sam Malone. All right, so let's see if we can dispense with that. Let's see what number 18 says. Peyton Manning, number 18. I'm on the wrong page again, 305. Number 18 says the integral of t squared I'm sorry, that's t to the 3rd. Division is the second thing to go. T to the 3rd, and then we have the square root of 2t to the 4th plus 3 dt. That's 2t to the 4th dt. All right. First, a rewrite. T to the 4th plus 3 to the 1/2. Get rid of the square root, write that as exponential form. See if you can see how far down the road you can get with this before you hit a snag. See how far down the road you can get. This actually involves a slight modification of what we've done before. So this is adding another layer of difficulty here. So see how far down the road you can get here. You might want to pause the video now and see if you can work this out, and then I'll catch up any stragglers when we get back together. So go ahead and pause now. All right, so let's see what we have here. I'm going to let u equal, it should be, I think, pretty straightforward by now. This is 2t to the 4th plus 3. What we have now to account for is the t to the 3rd and the dt. So we need to create t to the 3rd dt. Well, what do we inherit from the derivative is du. From the derivative, we inherit 8t to the 3rd dt. I don't want 8. I only want t to the 3rd. So can we get rid of this 8? Yeah, this is the same. This is the same problem number 16, I guess, isn't it? 1/8 du is equal to t to the 3rd dt, and the substitution is exact. right, and so now the substitution can be made. 2t to the fourth plus 3 translates as u. And t to the third dt, that translates as 1/8 dt. And so we have 1/8 times. This is now a basic form, power rule. This is u to the, let's change that a little bit here, u to the 3/2 divide by 3/2 means multiply by 2/3. And then what was u? U was this mess to begin with. So it's 2t to the fourth plus 3. You may combine these and write this as 2 over 24. But 2 over 24, you could also 2 into 8 leaves 4. So you could actually write this as, this is all to the 3/2 power. This is all over 12. You could write this as 2 24ths, but 2 24ths is clearly 1/12. And I think we're out there.